Leetcode 1143, longest common subsequence. It's a medium type problem and also a very famous one, so a lot of people heard about this, and initially it might sound very complex, especially because it deals with dynamic programming, or at least the optimal solution uses dynamic programming approach, but surprisingly, it comes down to a very simple check. So there is just two options once you think about this, and they're surprisingly simple, and we will come back to it and explain it and explore it together in greater detail. But first, let's read the description. Given two strings, text1 and text2, so we have two strings as input, text1 and text2, return the length of the longest common subsequence. So we don't have to mark or remember the subsequence itself, just the length of the longest common subsequence, which is a little bit simpler. And of course, if we had to store the subsequences themselves, then the problem would probably be already hard and not medium. And that's because it's just the length, then it simplifies the problem a lot, and we have to just return the integer, and so not the subsequence itself. And if there is no common subsequence, which also could be the case, there could be such inputs where they have no subsequence which is common at all, then we have to return 0. So in the worst case, we return 0. And here they explain what is a subsequence. So of course, there are various numbers of subparts or sub data structures on arrays, strings, and so on. And sometimes you have to preserve order. Sometimes you can take them in any order. Sometimes you can skip the elements between, and this is exactly the case. So here we have to preserve order, but we can skip some elements between. A subsequence of a string is a new string generated from the original string with some characters can be non-deleted. So we can skip characters, but we cannot reorder them. And of course, also each substring where you cannot skip characters is a subsequence. So subsequence is like a more general thing, without changing the relative order of the remaining characters. For example, ACE is a subsequence of A, B, C, D, E. And we will try to use that particular example to explain how I would approach that, and then we will translate it to Python by the end. So that will be our example to think about. And a common subsequence of two strings is a subsequence that is common to both strings. Very useful. So of course we want such subsequence which is found in both strings. And initially you may think that there are really a lot of possibilities because you may start from any character within the string. So once we explore this, then maybe we will have to go back and forth and so on, but that's not really the case. We just have to iterate m times n possibilities, or m times n cells in a grid of our options, and we'll come back to it in a second. And of course, m is the length of string 1 and n is the length of string 2, or vice versa, doesn't matter. But we only have to check as many characters or compared as many characters as there are here, but each character from this has to be compared with each character from that, and each character from this string with each character from that, which is the same thing. So basically m times n comparison. And here is some example to clarify further. A, B, C, D, E, of course, our example from here. And in this case, the output is 3. That's because ACE can be found here as a subsequence. We take A, C, and E. So the second string, complete string, is a subsequence of the first string, and its length is 3, and that's the longest common subsequence here. In the second example, they are both the same. So of course, the length is the length of the best common subsequence. And in the third example, they have no common subsequence at all because there's ABC and DEF. So all characters are different. If there is at least one shared character, then the common subsequence would be 1. But in this case, there are no shared characters, so the output is 0. So now let's copy this and let's think about it in greater detail. And by the way, like this. Why it was not showing? Longest common subsequence. And of course, we use dynamic programming approach. So let's write it down. And dynamic programming, as you probably know by now, since if you have arrived at this problem, you probably have already solved a couple of easier versions or easier problems related to dynamic programming, don't have a single formula. So there is not like just a single approach, as in, for example, backtracking, or in some other approaches where you have just like this one formula that you need to slightly modify depending on the problem. In dynamic programming, it's a little bit more complicated, since the only thing that is common between those types of problems is that they can be broken down into sub-problems. And the bigger problem is like the answer or the result for the bigger problem is arrived by combining the smaller results for those sub-problems. Yeah, so there are sub-problems, and we store the results somewhere in some form. We can either do it recursively, or we can do it iteratively and store it in some kind of array, or sometimes dictionary. And in this case, we will use a 2D array. Yeah, and each cell of this 2D array, or this 2D grid, will represent one character from text 1 versus one character from text 2. And that's it. That will be enough to cover all the options of all the sequences. Yeah. And once we have all the sequences or all the subsequences, then we can also check if they are common subsequences. Yes, if there is a match between subsequence from text 1 and subsequence from text 2. Yeah, so let me just write down that the length of this one, let's call it n, will be 5, because we have 5 characters. And the length of the other one, that's called m, will be 3. And in our case, we'll store the results. We store the results in a grid / 2D array called DP. Yeah, so usually, because dynamic programming, this additional storage is called DP, just for you to, whenever you look at the example and you look at the code, you already can see that there's DP there. You can make connections in your brain, or your brain sees already that this is probably something related to dynamic programming. So this is just a convention. You can call it however you want. And let's make it a little bit bigger. And I think that first we will just do a graphical example here. So you will see that n times m checks is enough to cover everything. And then we will try to make it a little bit more rigorous. And finally, we will translate it to Python. Yeah, so let's create that grid. And let's make it like this. The first column we leave it empty, or just with zeros. And this is just to make the code a bit easier to write. You will see it in a second why. Then we have next column for A. Then I'm taking the letters from here, C and E. And make it like this. And then on this side, the rows. And by the way, it doesn't matter which text or which string represents columns and which represents rows. So we can transpose it at any time. It's just a matter of preference. Either way, we have to go through each column. Not through each column, through each cell. D and final E. And let's create a table like this. Like this, and like this. And now just the columns are also necessary. And that's it. And the first row and the first column, we fill it with zeros. And here also all zeros. And for each cell, there are just the two options. Either the characters match or they don't match. Yeah. So either A and A, for example, here in this column, we have A from here, they match. So we do something. And in this cell, we have B from here and A from here. They don't match. We do something else. Yeah, so there, just for each cell, we have just two options. In case of a match, if the characters from both screens match, then we found one more character that we can add to the common subsequence. Yeah, if they match, we can extend the common subsequence. We extend the common subsequence by what? By 1. Yeah, because we only care about the length. We don't store the characters. We just store the length. We extend the common subsequence by 1. That's it. So simple. Let's make it like this. Make it a little bit bigger. And the second option is they don't match. So else we repeat the previous best result even easier than this. And that's it. Yeah, so now we have A and A for this cell. And of course they match. So we are here. What was the previous best result? Yeah, and now you can see why we needed those zeros to just check what was the previous best result. So the previous best result initially, of course, has to be 0. And for the first characters, because they match, we store 1. Yeah, and here there's no match, but the previous best result is 1, 1, 1, and 1. That's it. Then C and A. They don't match. The previous best result is still 1, 1. And now the previous best result, no, C and C are the same, so we increase by 1. And that's it. Now we put here 2, 2, 2, and 2. And finally here, E and E match perfectly to give 3. And sorry, I made one mistake. Here not 2 and 2, here are 1s, because the previous best result from the neighboring cells. So either to the left or from above. Yeah, since we cannot just check everything, we just check the best result from the neighboring cells, and that's it. Yeah, and in this case, the best result here was between 0 and 1, 1. Here between 1 and 1 is 1, and here between 1 and 2 is 2, up until we reach this place. And here, of course, E and E are the same, so we increase the previous result by 1. And that's it. That's the whole philosophy, nothing complicated. So now let's make it a little bit more formal. dp of I and j. And what is this I and j? This represents any cell depending on what I you will choose and what j you will choose. And of course, you have to choose between 0 and the number of columns, or between 0 and the number of rows. Yeah. And this represents what? It's the length of longest common subsequence, LCS, for the prefix which prefix? Between text1 till I and text2 till j. That's it. And in the code, of course, we won't leave them empty like we did here. First, we put everywhere zeros, and then we go one by one and do this one if-else statement inside a nested loop. Yeah, why nested loop? Because we have to go through each cell, and the outer loop will take care of the rows, and the inner loop will take care of the columns. And as I said, it can be in this form, or it can be transposed, so the longer one will go here and the shorter one will go here. Doesn't matter, the result will be still the same. Now let's take m and n. Do we need this? I'm not sure, but let's make it like this: text1 and text2. Then for sure we need the dp. Yeah, we'll need it here, and it will be 0 for underscore in range m+1, or underscore in range n+1. Is it correct? Let me just do something like this, m and n. Let me just run it quickly to verify if the syntax is correct. And because I want to create this grid out of range, because and I see two mistakes. So of course I swapped it, n and m here, and either we'll leave it like this. Let me just run. No, let's make it like that. Now it should be correct. And of course the answer is wrong, except for the case when, and there are no common subsequences because we haven't filled it yet, but I just wanted to check the syntax, since I don't always remember how those nested list comprehensions work, or some other syntax related stuff. And the problem with Leetcode is that it doesn't highlight the errors up until you run it first. So just wanted to verify that this one is correct. And now we can iterate through text1. So for I and character 1 in enumerate text1 starting from 1, the row will be dp of I, and the previous row we will need both for this diagonal check, and the previous row will be dp of I minus 1. And now we can go for j and character 2 in enumerate text2 also starting from 1. And now we have our two options. So either they are the same, and in this case dp of I and j equals something plus 1, or else and dp of I and j equals the maximum between those two neighbors. Yeah, so Let me think about it. Either the previous row, so one above, on the same J position, or the current row on J minus 1 position. So the one to the left. And by the way, we since I also took the row here, we don't need to do it as complex. We can just update it inside the row, since we have already took it out at this place. And here we go from previous row on the diagonal J minus 1. And so all three options, top, left, and diagonal left top, something like this. And here +1. So when we increase, we take, let's say, once we increase here at the blue square, we have to take the value from the green square. That's it. And when we have this else option, like let's say here, then we take the maximum between those two. And that's it. Let me think about it. Is it correct? Looks okay. So now let's run. And first 3 cases are correct, surprisingly. Now let's submit. And we are faster than 97% of other competitors.